Still going through our practice of U substitutions. So let's take a look at this next problem on page 600 in our workbook. So this time we want to find the indefinite integral of 2x plus 2 over x squared plus 2x dx. All right, and this is, I don't really want to say that it's great or not great. I don't know exactly how to do this. There might be other ways of tackling things like this. I could do all kinds of different things. There's all kinds of geometry that can be done with this. I can factor an x out here and do all kinds of mess. But the first thing that strikes my mind is that the numerator here is the derivative of the denominator. So that gives me an idea. Aha, let's take a look at our friend U substitution and see what happens. So we're going to let U be equal to x squared plus 2x. And so du is equal to, I'm going to take the derivative or the differential of each one of these terms. So that's going to be 2x dx plus 2 dx. If I were doing this for real, I would have gone right ahead and written it like this because I've got the dx at the end. But just keep in mind, the basic idea is that dx is part of each of these terms. All right, and so is U substitution going to help us in this case? Yeah, it is, because our denominator here is U, and 2x plus 2 times dx is what's in the numerator. And so I can replace that with du. And so this becomes 1 over u du. Okay, and what's the antiderivative of 1 over u du? The antiderivative, we want to be careful. It's not the natural logarithm of u, it's the natural logarithm of the absolute value of u. Because remember that the domain of the natural logarithm is just the positive numbers. All right, the natural logarithm function kind of looks like that. So when we talk about the natural logarithm of the absolute value of u, then we've got a function that looks like this, which has much closer to all of the real numbers as its domain. It doesn't matter much if this is something that's always a positive number, like if this were x squared plus 7, I would know that that's positive no matter what x is. But there are going to be times when this is a negative number, and so I need to be sure to have the absolute value sign there. And the last step we do is we're going to put x squared plus 2x back in place of u. All right, so this is an example of how we're going to use U substitution to pull out a natural logarithm of a complicated function. All right, the next problem is going to have its own quirks, but it's going to be something we've already seen before on this page. So give it a shot and see if you're able to tackle it yourself.